All right, you guys. So what I want to look at today is I want to look at how you can write an equation using the 5D process. So we've been talking about the 5D process. You've seen the table. You've seen what that's about. You've actually gotten to work on a couple problems that I'm going to do in a moment. And now we're going to write an equation. I know that some of you are already comfortable writing equations, and that's great. Still pay attention to this video. Still write down some notes just to make sure there might be something that I share that you haven't thought about in a while. So I'm going to start here. These are just kind of some general rules about writing equations, really from the 5D process. They're specific to this, but some of them are universal too. So the first thing I want you to make sure you do is when you're writing an equation, we're only going to use one variable. So this is an issue I see students run into all the time. They'll see two things they don't know about it. Maybe it's a problem about two sides of a rectangle and you don't know them. And they'll go, okay, I'm going to call one side X, I'll call the other side Y. That's not going to work for us. You're not going to be able to solve an equation that has multiple variables. Instead, other unknowns, meaning other things, like if there's two sides, the other side you don't know, should be defined by the same variable. What I mean by this is if one thing that you don't know, you're going to call X, and maybe you know that the other thing is 3 less than twice that. Well, then you'd write the other thing as 2x minus 3. I know out of context this might be a little confusing, but notice that the second unknown thing is still using the same variable. It actually is that x right there being used in our second expression. That's going to help our equation be useful for solving. The second thing, and actually make sure you write down at least these top parts here. I think you might want to write down the examples too, but write down at least the bullet points. The second thing is to use the define section of your 5D process to create your equation. So what we're going to see is if you're showing your work in the define section like you're supposed to be, so let's say I have a situation where I have two sides of a rectangle and I know that one side is a number and the other side is 3 times that number. Well, if my work says 5 and then for side 2 I have 5 times 3, to make those into an equation with a variable, it's a lot easier because now I just write x. And over here, I change that to x times 3. You'll just be able to take the numbers you were plugging in from the 5D process and now just use a variable instead. What do I have? One more point here on this page, and then we'll do a couple examples. Usually the do section will help you write the actual equation. And what I mean by that is if you were in your do section, let's say, again, I'm pretending this is a problem about a rectangle. Let's say you have two sides, and then you have to find the perimeter. If I'm showing my work here to find the perimeter, 5 plus 5 plus 5 times 3 plus 5 times 3. Now I can change this into an algebraic equation by just plugging in x for each of that unknown 5. So now it just becomes x plus 5 times x plus 5 times x. All right, so again, make sure you wrote down each of those sections there. Let's take a look at two examples that you actually just worked on. So you might already know the answer to these problems, and that's great. But I want to talk about how we write an equation here. So, looking at the first one. A triangle has 3 unequal side lengths. A medium side is 7 inches longer than the short side. The long side is twice as long as the short side. The total perimeter is 39 centimeters. So, I'm going to kind of skip past my describe draw section and I'm going to go straight to the, I always blank on this, but to the define section. So if we were looking at the define section, you would have 3 things to find here. You would have the short side, you would have the medium side, and you would have the long side. And I want you to look at something here. I want you to notice the way they describe the other sides here. They say the medium side is 7 inches longer than the short side. And the long side is twice as long as the short side. When you have two sides that are based on the short side or based on a single side here, this is the one we're going to define as x. You're going to call this your missing variable x because you're going to be able to write expressions for the other two sides based on x. Let's start with an example just to get you started. Let's pretend you tried this on your own and you tried, let's say 3 for the short side. And you said, okay, the medium side is 7 inches longer, so that's 3 plus 7. And now the long side is twice as long as the short side, so that's 2 times 3. Well, when you go to make this an equation, like I said, you find the part that the other parts are based on. So the short side is kind of our building block here. I come over to my define section, I'm just going to make the short side into x. That means it's some number I don't know. Again, we're doing this as if we haven't already solved the problem. Now write the other two sides based on that x. So if the medium side is 7 inches longer than this, I write x plus 7. If the long side is twice this, I write 2 times x. Now, when I go to actually make an equation, the do section is going to be helpful here. So like I said, look at the do section. In this case, this problem was about perimeter. So in the do section, originally, you were using these numbers here. So you would have written something like 3 plus, and I'll use a little bracket just to separate them, 3 plus 7, plus another bracket here, 2 times 3. Those are just for organization. Now to make my equation, I'm going to do the same thing, but I'm going to do it with the variables. So instead of 3, I'm going to write x. Instead of 3 plus 7, I'm going to write x plus 7. And instead of 2 times 3, I'm going to write 2 times x. Your last step here, because we've done some combining like terms, is to, I'm sorry, I didn't finish the equation. So there's my expression. Now, we know that we want this whole thing to be equal to what? Well, we want it to be equal to 39. So that's how we're actually going to make this equation. We're going to set it equal to 39. So that's an algebraic equation that shows the relationship here. It says the short side plus the medium side, that's 7 inches longer than the short side, plus the long side, which is twice the short side, equals 39. And now what I was getting to there is now we're going to combine like terms. So you know you can combine your x terms here, x plus 2x gives you 4x. The 7 is the constant, just leave it. And for now, we're right here. We're not going to get into the solving the equations yet. I know some of you already have. We already saw a little bit of that today. I know you guys have seen some of it. So if you're ready to solve it, that's great. Subtract 7 from both sides, divide both sides by 4. But you don't have to do that right now. Let's look at one more example here in this video, and then we will be, we'll come back to class. So Travis and Angela were playing a guess my number game. Angela told Travis, I'm thinking of 2 positive numbers. The difference of my numbers is 4, and the product of my numbers is 96. What are my numbers? We're going to use a similar strategy here. So in our define section, now this one could be a little different. We have 2 missing parts. We have the 2 numbers that we're missing. But we're given a difference and a product. So one thing you might have been unsure about is which one goes in the define section, which one goes in the do section. Well, what'll help you to think about this is if you think about this step here. We're trying to only use one variable. So in my define section, I need a rule that's going to help me figure out the second missing number based on the first number. If I know that the product of my numbers is 96, I know that something times something is 96. That's a little harder to write an expression from. But if I know that the difference of my numbers is 4, that means that one of my numbers is 4 more than the other number, or 4 less than the other number. So what I can do is I can use my define section. I would use an example like, let's say I used 8. Well, then my other part has a difference of 4, so I would do 8 minus 4, which of course is going to equal 4, but we just need that expression right there. So when I go to write this as an algebraic expression, I'm going to call the first number x, and the other number, based on that x, will be x minus 4. So this is showing a number and a number that is a difference of 4 from that same starting number. Now the do section is where we're going to use the product here. So we know the product is 96. So originally you would have done something like, okay, 8 times the difference of those 2, which I'll write it that way just to communicate it better. And this one wouldn't have worked, but we can at least see that. When we go to write it now with our variables, I'm going to use this number and this number, x times x minus 4, and now we set it equal to whatever it's supposed to come out to, which in this case is 96. And there you can see an algebraic equation that shows the relationship between those 2 numbers. A number and a number that has a difference of 4 from that first number multiplied to 96. All right, so there's a little bit on how you write equations using the 5D process.